This is day 3 of weak versus strong. We're going to be dealing with bases today, and then we're going to continue on with the topic of salts. So we did two things today. We went over weak bases that aren't normal weak bases, and then we started in salts, and then we will have an assignment for that. So let me minimize and let's begin. The PowerPoint again is up. It went up all as one big PowerPoint. This will be on the 11th slide of the PowerPoint. Okay. Most bases do have OH, a hydroxide in them, but there are some that do not have an OH. When we doesn't have an OH, then when we write our equation, we're going to have to put water in it. One of those cases is something called an amine. Amine is in a special group that has NH2 on the end of it. That's how you can recognize an amine. See if I can get my pen to write here. Here's an example, CH3. This ending here is an amine, and it relates to ammonia compound, and let me show you how that works. Ammonia is usually NH3, so it looks something like this. Amine group has one of these hydrogens removed, and so instead of being an NH3, it's got some sort of carbon compound connected. If you go into organic chemistry, you'll learn a lot more about amines as you study, like maybe in AP Bio, or someone said today in Anatomy and Physiology, they talk about an amine group. This one's called a methylamine because this is one carbon, meth means one, so this is called a methylamine. If I were to have two carbons here, this would be known as an ethylamine. If we had three, it'd be a propylamine. So you can kind of see, but the key here is that ending there. So let me go back to the PowerPoint. So when we have an amine group, it is going to be a base. And so in order for us to see it, we have to put plus water. And what happens is one of the hydrogens come off of the water molecule. It actually acts as an acid in this case. And it will go and it will attach itself to the end of an amine group, and then it becomes a charged particle. So you take the hydrogen off, put it on the end, it becomes a plus, and then you're left with OH. The reason you want to write it that way is you want to be able to see that OH. So this is how we would write an amine. And then sometimes we'll be given a conjugate base. And so if we have a conjugate base and we are asked to write this, a conjugate base, you still have to put it in the water molecule. The water molecule, the H still comes off, and this time instead of going on the end like it did here, it actually goes into the beginning, and then you get that acid in which we make, and then the water will be left with an OH, and you'll be using Kb instead of Ka in that case. So let me give you some examples. Well, that's our amine group. But if we had, let's just do acetate here. Acetic acid. That's the acid part. This would be his conjugate base part. So there's the acid, there's the conjugate base. If you have HCl, that's the acid. That's the conjugate base. Do you notice what I'm doing? This is the acid, this is the conjugate base. The conjugate base always has a hydrogen removed. If we had H2SO4, that's our acid. This is actually the conjugate base here, one of the hydrogens removed. So the acid has the hydrogen, the base has one of the hydrogen removed. Kind of when we were doing that worksheet, that's what we were doing. But now we're going to start referring to them as the acid and its conjugate, and being able to see that in the problem. So if you have a conjugate, you can take a hydrogen off the water, it'll go in the front, you'll form that acid, and then you'll make OH, because we're going to be rising these type problems. Apparently we've got that double click there. Alright, so one of the problems that we did today was to calculate the molar concentration of OH in a 0.05 molar solution of ethylamine, and it's called ethyl because it's got two carbons, and it's an amine. You can see that. So the first thing we would want to do, we are going to be rising. When we go to write this, because it's an amine, we're going to put plus water, And amines, we take one of the hydrogens off and it gets stuck on the end. We're going to draw a double arrow. So then it makes this weird looking ion thing here. That's a +1 because this was 0. You put a proton on it, it becomes +1. And then water is going to be left as OH. It's real important to see that OH there. And then, just as we erased before, this will become 0.05. The water is not important. It's not that it's not important, but it doesn't affect our equilibrium, so we're going to just scratch through this. We got 0, we got 0. You've got -x, you've got +x, +x, 0.075 -x. We've got x, we've got x. You're going to end up with x squared over 0.075 minus x, and we would set that equal to, we're going to set that equal to the Kb, because this is that OH. And now you can either scratch through this and then cross multiply, or you can use the solver. I forgot the answer to this, so I'm going to stick it in the solver very quickly. So, if I could pause, let's see if I can find the pause thing. Maybe not. Okay, so now we've got x should equal 6.62 times 10 to the -3rd power. Now, if it had asked for the concentration of my amine, I could take 0.075 and subtract that. If it asked for this ion, I would already have it. And right here is the guy that I'm really wanting, is that hydroxide. So I'm looking for pH. Well, he's not going to get me pH, but I can get pOH of him by taking the negative log. So I can do the negative log, and I still have my x stored in there, so I'm just going to do negative log of x and of that. So that's going to get you a 2.2 on the pOH scale. So to find pH, you subtract it from 14, you get 11.8. And you could find the percent ionization by taking x divided by I times 100. So the only thing that makes this one difference is, one, it's a base, so I've got to subtract it from 14 to find pH. And I have to be able to figure out how to write this equation, so that's the hardest part of that. So not too bad. Let's go on to the next. That is the end of that PowerPoint. So we finished up that day 3 on that one. So some of the homeworks are like that. So let me minimize that. And we're going to OK that. We're going to now find our salt PowerPoint, which was the second thing that we did. And it had 7 slides here. Alright, the first part of this is just has pH plus pOH equal 14, and hydronium times hydroxide equals 1 times 10 to the -14. There's a relationship between the Ka for an acid and its conjugate base, which is the Kb. If you multiply those K's together, you'll get Kw, which is that 1 times 10 to the -14. And you can actually figure out which acid is stronger by looking at the Ka values. The larger the Ka, the stronger the acid is. So on this first question, I'll go ahead and click all the questions. That way I can write and then... Alright, it says, given that the Ka for acetic acid is 1.8 times 10 to the -5th, and that of hypochlorous acid is 3.8 times 10 to the -8, which is a stronger acid? So all you have to do is say, well, which one of those numbers are bigger? The bigger the number, the stronger the acid. And our stronger acid is going to be this, because it's to the -5th. This goes to the -8th, so the acetic acid is a stronger acid. This question says, find the Kb for, notice that this is the conjugate of acetic acid. This is the conjugate of hypochlorous acid. So to find the Kb for this guy, I would take 1 times 10 to the -14, and I would divide by 1.8 times 10 to the -5th. And you would find that it's 5.6 times 10 to the -10th power. I do the same thing for this one. Oops, 3.0 times. And you get 3.3 times 10 to the negative 7th power. So those are my answers for number 2. Very easy to do to go from that. It says, which is a stronger base, the acetate ion or the hypochlorite ion? And it's not going to be a strong base, but it's a stronger, more basic counterpart here. And again, it's going to be the one with the larger number, so that is going to be the hypochlorite ion. So if you'll notice, the stronger the acid, the weaker its base. And the weaker the acid, the stronger its base. So that's how you can tell. So you could have actually be able to answer question 3 without having to do part B. I just wanted to show you mathematically. So the next part of this PowerPoint says the stronger the acid, the weaker its conjugate base, and vice versa. Okay, definition of a salt is a product of an acid and base reaction. So salt is pretty much an ionic compound that's formed from the cation of an acid, the cation of a base and the anion of an acid. And all salts do something called hydrolysis, and that's what's going to give us a little bit of trouble in chapter 17, but we're going to be okay with it. And we can kind of predict the pH of an acid or a base by looking and kind of figure out maybe what formed it. If a salt is formed from a strong acid and a strong base, then it's a neutral salt. For example, NaCl, I'm just going to click all of these before I can write. NaCl is a product of, I can go over here for this one, probably sodium hydroxide. The first part, the cation, comes from a base, and this is from the acid part, which is HCl. So this is a strong base, this is a strong acid. If they're both strong, then this is a neutral salt. If we look at this one, we've got LiOH probably was the base that formed it, and then HNO3, and again that is strong, so therefore it's a neutral salt. This one here, probably NaOH, and HCl, which is hypochlorous acid. This is strong, but this is weak, so therefore this is a basic salt. This one probably came from barium hydroxide and acetic acid. So this is a strong base, a weak acid, so it's basic. This one's unique, probably came from ammonia, which is a weak base, and hydrochloric acid, which is a strong acid, so therefore this one's acidic. So if it's a weak base, strong acid, acidic, strong base, weak acid, basic, strong, neutral. What if they're both weak? Well, if they're both weak, you actually have to look at the Ka and the Kb, and whichever one's bigger would decide whether it's acidic or basic. So if it were been made from 2 salts, you would have to compare the Ka of the acid and the Kb of the base, and whichever was a bigger number would be determine whether your salt is acidic or basic. And sometimes they're close to neutral too if their Ks are very close to each other. So we just practiced these examples, and one of the homework assignments is having you do this. So I'll do it very quickly. It is getting close to 5 here. So this would probably be made from aluminum hydroxide and nitric acid. So this would be a weak base, and this is a strong acid, so therefore this one would be a basic salt, more of a base. This one's made from cesium hydroxide, which is a strong base, and hydrobromic acid, which is a strong acid, so therefore this one would be neutral. This one's made from KOH and H2SO4. This is a strong acid. This is a strong base. This one again would be neutral. This one's made from KOH, strong base, and HCN, hydrocyanic acid, which is weak. So this one would be basic. See if you can figure this one out. This one's probably made from an amine, which is a base, and hydrochloric acid. So therefore this one would be acidic. Simple as that. That's not hard. Alright, so let's calculate the pH for the following. Well, first off, I'm going to work with this one, and then I'll work with that one there. This is NaCl, which, if you broke it down, that's actually a neutral salt. So the pH of a neutral salt is actually going to be 7. I'm going to work through the math very quickly and show you why that would be. When we start with the salt, we're always going to take a salt, and we're going to put it in the water. And you're really going to want to you're really wanting to do the net onyx of this. This is going to make the two things that we think made in. So we really think it made NaOH. This is called hydrolysis. It actually goes back and a little bit makes the two things that we think made it. So there's what we think is going on. Put it in water, slightly does this. But we're going to now do net onyx. This would slash because it's a first family. Water's going to box. This is going to slash strong. This is going to slash strong. So now let's just get rid of some spectators here. Let me go to a better chord. This is just going to be a spectator floating around. This is going to be a spectator floating around. So the real equation, that what's really going on is water breaking down. And so if we think about it, first off, if we were trying to rice it, which we could, notice that that's a spectator, I took this out. So that 0.1 molar there is kind of irrelevant. And water's kind of irrelevant too because it's not in the equation. This starts out at 0. Well, if you had x and you had x and you had x and x, there's no bottom. You would end up with x squared. It equals kW because that's water, which is 1 times 10 to the negative 14. So if I take the square root of that, you would find x is 1 times 10 to the negative 7. If you will look to find pH, I need this one. If I took the negative log of that, you would find the pH is 7. So I just proved it mathematically to show you that a neutral salt actually they'll all look like this. They'll all be water and that. Unfortunately, this guy down here is not a neutral salt. So he's going to give us some problems. So let me get this erased. So we're going to start out with NaC. And then we're going to put plus water. And this is going to make HCN. And it's going to make NaOH. And you really do want to do the net onyx of this. So this will slash. This will box. Unlike the other one, this is weak. It will box. And this will slash. So our spectators here are the sodium. And that's it. So when we get ready to rice this guy, we actually have some Cn minus 1 plus water makes HCN plus OH minus. Now the water we don't care about. The sodium cyanate was 0.5, so 0.5 molar. In the beginning this is 0. So you're going to have minus x plus x plus x, 0.5 minus x, x, and x. So we're going to get x squared over 0.5 minus x. And then we're going to need to set that equal to, we got to decide, is it an acidic salt or basic salt? This is a basic salt. It's not a base, but a basic salt. Or you could see, if you do the netonics, you can see this OH here. We've got to set it equal to Kb. So I meant to put on the PowerPoint, but they should give you for HCN, the Ka for this is 4. I think this is right. It could be, but we'll just go with this number for now. And there's a chart, Appendix D, in the back of your book. So if you're looking for a Ka or Kb, they're in the back of the book, in the appendix. So, but this is Kb, but what they're going to give me is Ka. I don't want to use Ka. I'll get the wrong answer if I use Ka. I need to use B because this is a basic salt, not an acidic salt. The Ka is for this thing, but I'm looking for this. It's conjugate. So how do you go from one to the other? Well, you take 1 times 10 to the negative 14, and you divide it by 4.9 times 10 to the negative 10th. We're going to divide those out. You get 2.0 times, we'll just go with 2.0 times 10 to the 5th. Times 10 to the negative 5th here. Alright, so now we need to solve. You can use your solver, or you can eliminate that bottom minus x. I'm going to eliminate the bottom minus x just for time's sake here. And I'm getting 0.00316 for my x. It's very late, so I'm hoping that's right. 0.00316. Now if I go back and check, if we've lost our thing what we're doing, we're looking for pH. That's OH. I can't use him. That's not H+. I can't use any of them. But I can use hydroxide. And again, that's one you want to use in netonics. So I need to find the POH by taking the negative log of that number. So we'll do the negative log. And I get 2.5 as my POH. So 14 minus 2.5. You'll get 11.5 for your pH. Even though that's a salt, it's got a pretty high pH. And that's how you would work a salt problem. Okay. Alright, I've worked all the problems that you need to be able to work the homework for this lesson. I will tell you on this particular slide, I did work this particular essay with them, which has all these parts to it. So you want to borrow someone's notes and work through and look at the essay that we did, because you might see an essay like this on your test. But I've given you enough information to be able to work the homework in case you were absent. But I do encourage you to get this from someone. I do have a handout of this PowerPoint, but you want these last couple of slides where the essay is worked out for you. Okay, well, I'm going to end now because it is getting late. So if I can find where the recorder is, and we're going to stop.